Part E, momentum transfer. In many problems involving fluid motion, it is not possible to have an accurate estimate of energy losses between different locations along the flow, which is meaning that the energy principle can't be used on solving such problems of fluid motion. In many of these problems, a reasonable solution is found by using the momentum principle. If m is the mass and v is the mean velocity of this mass, then the linear momentum of this mass is m multiplied by v. Take into consideration that the relation between calculation momentum at positional velocity and mean velocity known as momentum correction factor or Bousinisk coefficient. Follow up, my dear, and note that the rate of momentum change is in fact equivalent to a force working in the same direction as that along which momentum changes. For the application of momentum equation, a suitable control volume is chosen so that the flow either entering or leaving is normal to the control surface, as shown in the enclosed figure. Look, my dear, and take in consideration that in applying the momentum equation, care should be taken to establish the component direction clearly and to use the proper sign for each term in the equation. The sign determination depends upon two factors, whether the term represents influx or a flux of momentum, and whether it is in the positive or negative direction of the component axis. Dynamic thrust of a jet on a fixed stationary plate. When a jet strikes a fixed stationary plate in any direction, the jet will be deflected by the plate. To facilitate the analysis, many assumptions are usually taken into consideration, which you can follow by yourself as written. It is so easy. A simple figure showing the striking jet on fixed plate at constant velocity at many cases and conditions. The rest of the previous figure and applying the momentum principle in y direction following the same sign system as shown. Follow up the equations and applying the momentum equations by using the shown sign system as shown. The rest of applying the momentum equation, follow up, my dear. The continually applying of the momentum equation, follow up. And note that the resultant force on the plate will be normal to it, while if theta is 90 degrees. The above equation will lead to Q1 must be equal to Q2 as shown. Dynamic thrust of a jet on a moving plate or vane. If a jet takes a vane that can be moved, this vane or plate will move under the action of striking jet. If the absolute velocity of jet as it strikes the plate is v, and as it leaves the plate is v1, hence, if the absolute speed of plate itself is epsilon, the effective velocity at entry and exit to the plate will be the relative velocity vr and vr1 at entry and exit respectively, as shown in the enclosed figure after. Simple figure showing a striking jet on moving plate or vane, as you see. The relative velocity at inlet Vr, which is equal to V minus epsilon, and it is the same at outlet, unless there are applicable friction losses along the plate. The direction of the absolute velocity of water V1 at exit depends on the magnitude of both Vr and epsilon, and the velocity triangles at entry and exit as shown in the previous figure. Note, my dear, It is important to note that if a series of straight plates are fixed radically on a wheel which allows to rotate around the shaft and its center, and the jet is placed tangential to the perimeter of this wheel and is allowed to straight on the series of plates, hence the wheel will rotate under the action of jet. It is an important reality. Moreover, the output power obtained equals the rate of doing work in the direction of rotation. Follow up, my dear, and the mathematical calculation of the efficiency of wheel, etc. The rest of previous equation of calculation the maximum eta as shown. Sample figure showing streaking jets on a series radically placed rotation wheel. Look, my dear, it is important to note that to improve the efficiency of the wheel, curved plates will be used instead of straight plates, as shown in the previous figure. Continue calculation of the efficiency of wheel eta and velocity also. Follow up, my dear, the mathematical calculation of the maximum efficiency of rotation wheel obtained when theta equals 180 degrees. Reaction of jets on body. The force caused by the jet of fluid issuing from a nozzle or an opening fitted to a sharpened body will act on this body in a direction opposite to the velocity direction of jet. In evidence, it will be of reaction force. If the body is free to move, it will move at the velocity epsilon in an opposite direction to the velocity v of jet. Here is some example of various cases of reaction jets on different bodies as shown in the figure after. Follow it by yourself, my dear. Simple figure showing the reaction of jets on bodies. More than another reaction of jets on bodies. Generally, the reaction force depends on the magnitude and direction of both V and epsilon, and also upon the area of nozzle and density of fluid used for creating the jet. Follow, my dear, it is your easy example of working pump in a foot. Follow up the mathematical calculation of the efficiency eta. Forces acting on a pipe pen. A pipeline carrying fluid will be subject to additional forces when it changes its direction, as at case of pen. A special anchorage arrangement should be made to resist these additional forces. It can be achieved by constructing a large concrete block to which the pen is installed by suitable blocks and placed enough to resist the resulting hydraulic forces, as shown in the enclosed figure. As shown in the previous figure, the bent angle is theta, and at upstream of the bent section 1-1, the velocity is v1 and the pressure intensity is v1, while at the downstream of the bent section 2-2, the velocity is v2 and the pressure intensity is v2. The two velocities are related together from continuity equation, knowing the cross-sectional areas A1 and A2 as the two ends of the bent. P1 and P2 are related also together from terminal equation, knowing the velocity V1 and V2 and the head loss between the two stations. Head loss through mouthpieces. Mouthpieces are a fitting used in conjunction with orifice and opening for the purpose of increasing the charge of flow from this orifice or opening. Among well-known mouse species are the border mouse species, have short or long syringe. Also, the diverging or accumulating mouse species is one, as shown in the enclosed figures after. A sample figure showing the head losses through the different types of mouse species. Follow up the applying of Bernoulli equation for calculation the actual discharge. Take in consideration, my dear, in your calculation that the coefficient of discharge CD for long cylindrical mouse species is 0.845, while it is equal to 0.970 for the same time has an inside rounded edge, and for short mouthpiece the coefficient of discharge will be around 0.65 as shown. Table showing the relation between coefficient of discharge CD and values of accumulated angle theta of mouth species. Also some reference might be. Additional references. It is fantastic. More references, my dear. Goodbye.